Okay, so hopefully you got this right here. I ended up filling it out. So when we had -1, -3 is not going to work, 0 doesn't work, but 3 does. And then we have -3 for 0 doesn't work, 0 does work, and 3 works. For x equals 1, -3 is a yes, the rest are no. And for x equals 2, y equals 0 is the yes. So now what we're going to do is we're going to input or put them into the G set. So it's already got the first one for us, -2, 0. So now we're going to go on to the next one that works, which is going to be y equals 3 and x is -1. So for -1, 3 is the answer. For 0, it's 0 is the answer, so 0, 0. For x equals 1, it's going to be 1, -3. And for x equals 2, y is going to be 0. So 2, 0. So those are going to be the ordered pairs that we're going to get. Those are the ones that are going to work. So this is a beginning for it. So when we're graphing y, and the y equals f of x, we are actually testing all the numbers on here. Well, in this case, integers, but we'd be testing a bunch of different integers to see, okay, which one works for this x, for this x, for this x, and so on. So that's kind of the difference. Last time we were plugging in numbers and seeing what we got out. This time it's more of a running through different y values and seeing which ones will work. So this next one says plot the solution of set G in the Cartesian plane. This is our xy. So I'm actually going to give you a little bit of time to do that yourself. Once you're done, just end up push and play and you can continue on. Okay, so looking at the ordered pairs we had last time, they were all right here. -2, 0 was already graphed for us. And this next one is going to be -1, 3. Next one is 0, 0. And then we have 1, -3. And 2, 0. Okay, so we plotted them. Again, this one is a lot like last time. When we have integers, we are not going to end up graphing them or drawing a line. If we were to draw a line, we'd say all the different values between there, but we're just looking at integers. So that is going to be where we stop for this one. Okay, so the next one, it says it's exploratory challenge 2. So the program code in exercise 3 is a way to imagine how set builder notation generates solution sets and figures in the plane. So given a function, f of x equals x, yeah, that thing, with domain and range, all real numbers. So now we're working with domain and range is all real numbers, not just integers. It says a slight modification of the program code above can be used to generate the graph of the equation y equals f of x. So if you remember before, we said x is integers. Now we actually have this coordinate plane. And so now we have x is all reals, and then our y equals f of x. So whatever our f of x is, whatever our function is, that's now going to equal our y coordinate. So our function of x, so whatever value we get of x, is now going to equal y. So now that's our y coordinate. So right below it says, even though the code below cannot be run on a computer, students can run the following thought code in their minds. So this is one that we just kind of have to think about and conceptualize. So same thing, declare x and y is a real. And so we're going to let f of x equal that wonderful thing. And so we're going to put in set notation and for all x in the real numbers. So if we were doing this, we would have to go through every single real number. That's kind of impossible for us to do, but that's kind of what they're looking for. So for all y in the real numbers, So again, we'd be scanning for all real numbers that work for each x. So if y equals f of x, then we're going to add it. If it does not, then we append it. So I don't know if it has an example on the next page. Oh, okay. So we would run through a couple of these, and I actually want to see if you guys can graph this first. So again, this is very similar to this one up here, but now we're working with real numbers. So I want to see what you guys can do, and then we'll check ourselves. So take some time, try that one on your own, see if you can end up coming up with some values and then plotting them as well. Okay, so looking at this, hopefully you guys found some points. If you didn't notice, this is the exact same as the last one. Our equation's actually the exact same. So we can actually use the same equation to come with a couple values. So for this one, we'll just write it on here. So on this one it says declare external real, all that we talked about before. So we could plug in numbers. So if we plug in -2 again, then we're going to see f of x equals, so it's going to equal, actually, I'm going to replace this x with -2. So -2, -2, and then we're also going to do -2 minus 2 times -2 plus 2. And so when we run this through, like we did last time, we end up finding out that it was -2 times -4 times 0. So f of -2 is going to equal 0. So what this means is we're going to look up here. So if y equals f of x, then we're going to add it. So we would scan through all the different y values, and we would find that the y value that is correct is going to be 0. So our x coordinate is -2, and our y is 0. So then the next one, we would keep on going, and we are going to get the same points. So we get -1, 3, and 0, 0, 1, -3, and 2, 0. So, but it's all real numbers, so we could actually go another one. This one has space for -3, so let's just try -3. So we'll write it down here on the bottom. If I have space, let me see. Okay. So we're going to do f of -3. And actually, if you want, then you can pause it right here, see if you can do it, and then start it back up again. Okay, so f of -3, we're going to plug in -3 in for each x. So -3 times -3 minus 2, and then -3 plus 2. So we're going to -3 times -5 times, what is this going to be, -1. Right, I did that correctly? Yep. Okay, so -3 times 15, or 5 is going to be 15 times -1. So that's going to end up equaling -15. So we obviously don't have space on there, but it just kind of gives us a better idea. Because actually I was thinking maybe we would come down and go back up. This is one of those that, now this part down here is just going to keep coming down. So just kind of an interesting one to add. Our y would equal 15 in this case. So if we're graphing this, we have -2, 0. We have -1, 3. 0, 0. 1, -3. And 2, 0. So this time it's going to be all reals. Here's how we would actually go about doing this. So we can just end up drawing lines and connecting them. That's how we would mostly take this and think about this. What a better way to go about doing it, and the way that a program would go about doing it, is it would run through all the different y's and see which ones are correct for each given x. So for this one, it would go through and it would scan right next to this -2, the next number. Pretty close enough for it's pixelated, and it'd say, okay, the next number is going to be right up here. And then it'd go over again and scan and say, okay, that is the one that satisfies. And it would keep on going, and it would end up moving it up, coming back down. This is poorly drawn. There we go, that looks a little better. And then it'll come back up. I'll erase that there. Okay. Something like that. So it's actually scanning over each time. So it's actually making a vertical line. So let's just say we're looking at the next one here, or we're trying to find this. It would scan this vertical line and see, okay, are there any values that work? And it's just checking them all. So I'm actually going to make this a dashed line so that you see it's doing this. So it's checking this whole line to see which ones are correct. So this one would be correct. So if you remember, in a function, each x, or input, it should only have one output. So each x will lead to one output. So if this is a function, output, this is a function, only one number on this line should work. So as we're scanning the computer, or if we were running through all these different y values, we should see, yeah, none of these work except for this one right here. And that's how we know it's a function. Another way we can think about this, or another equation, would be something simple. F of x equals, let's just go with 2x plus 1. Something along those lines. Something fairly simple. So I'm going to graph that over this one, but I'll do it with a dashed line. So dashed line. That's how I'm going to be graphing this one. So -2, or 2x plus 1. So if we were to plug in 0, 2 times 0 plus 1, we're going to get 0 plus 1. And so our f of 0 is going to equal 1. So our y, for that to equal, we'd have to say our y equals 1. So again, it would scan all of them. So we end up putting a point right there. Okay, so actually, this is a good time to stop and give yourself a chance to go through this thought exercise and kind of figure out where this line would be going, what would be going on. So just pause it here and give it a try.